Hello, everyone. Welcome to this presentation, this webinar about how to teach a class of autonomous mobile robots. So let's go straight to the point, and then at the end of the presentation, we'll have the chance to do some questions and answering. So please take note of your questions while I am explaining here about this subject. So what is my goal here in this presentation is to show you a way to teach a mobile autonomous robots course. But the special thing, so there are many mobile autonomous courses, robot courses around the world, but the main thing here is to use ROS for making the students practice. And what are you going to learn along this webinar is first, I'm going to give you, not in this order, but I'm going to give you a list of the robotic subjects that need to be taught in a course for mobile autonomous robots. Then I'm going to give you the guidelines about how to integrate those subjects with ROS learning. So the students will learn at the same time the autonomous mobile robots concepts and ROS. So I'm assuming that the students that come to your class, they don't know any ROS knowledge. And then we are going to move into how to use that ROS knowledge that they are learning at the same time that you are teaching the robotic subjects. So how to use that knowledge to practice the theory about the autonomous robots courses. Then at the end of this presentation, I will give you some examples. So I will give you some code, some projects, what we call a ROSject, that you can use in your own classes or that you can take as a template, as an example for you to build your own material for your own classes, following this procedure. Okay, so maybe you are thinking, who is this guy who is talking to us and why he can teach us something about that subject? Well, my name is Ricardo Tellez. I am CEO of the company called The Construct, that we provide online web-based systems for programming robots with ROS online using a web browser. So you don't need to install anything on your computer. And basically, I'm using all these technologies that we create in our company for teaching a robot navigation class at the La Salle University in Barcelona. So if you, whatever happens that you are around here in Barcelona, please come and visit us. You can come to my class also, and I'll be happy to show you how we do the classes there. Okay, let's go. So what is the problem? Okay, the problem that we are trying to solve here is that when I see that when I'm teaching about autonomous mobile robots, the students, they see all the theory about the equations, the probabilities, the Kalman filters, and all that stuff. It's super boring, and it's hard to find a way of using this into something useful. Actually, after all, the student is there because he wants to learn how to make a drone fly from one room to another, or how to move an autonomous car from one point to the city to the other. So how does it relate to all these probabilities and Kalman filters around there? So that is the problem that I'm trying to solve. And my proposal to solve this is to start by making the students do things instead of just receiving the information about how we have been doing all those subjects in the last year. So we know how to do this, okay, how to make a robot navigate. But there is a theory and we know that it works, but the student doesn't know anything and how it relates. So what I propose is that we start by making the students learn those subjects by doing. And I also propose that we use ROS as the base, as the backbone, that allow us to attach those practices to the theoretical concepts of robot navigation algorithms. And then this means that the students must start by implementing the theoretical concepts that of those algorithms by using ROS. And I want to show you this image because just to clarify what I mean. So I don't mean that the students will have to create a program in Python that shows something on the screen, like you can see on this image. That it's in this case it was an algorithm for localization, and it is using the algorithm in this kind of simulated environment with very artificial things, very artificial points, very artificial results. So I don't mean to make the student create this algorithm here for that situation. What I mean is that we make the student create the algorithms for make a robot, an actual robot, do the task that we want the robot to do. In this case is, for example, in this image, you can see the robot, this Tiago robot from Power Robotics, that is creating a map from an environment. On the right-hand side, there is the simulation of the robot, and on the left-hand side is the map that is being created by the robot. So what I propose is that the student create the algorithms for making that robot, that simulated robot, create a map, for example. Okay, so that the student has to deal with real stuff. I mean, he has to get the data from the laser sensors, and he has to send commands to the wheels. So that's what makes, from my point of view, of course, that what makes the student understand very quickly the different subjects of autonomous robots, because he understands why is this necessary, because he's trying to apply to a real robot, even if it is in simulation. Okay, so if you like this idea about using ROS applied to robot simulations, and in order to implement the algorithms and apply into those robots using ROS, then let's see how to do that. I will give you some steps in order to create your material for your students following this methodology. And, okay, so in the first step, so we are assuming that the students doesn't know about ROS. They have heard, but they don't understand. They haven't studied yet. So in order to start your class, so you first have to start by providing a class teaching the basics of ROS. So just the main basic things. You don't have to be explaining everything about ROS or the whole theory about ROS. Just the main basic things. That list I have compiled here, you can see on the slide that it's about the main basic ROS concepts that I think that are the bare minimum that you have to teach to your students. And I can tell you that you can teach this in a class of 3 hours, for example. Yeah, more or less in those 3 hours, you can teach those subjects, not very deep, but it's neither important to teach this very deep, because the students are going to practice this along the rest of the classes. All the time are going to do the same thing. They are going to subscribe to the topics. They are going to publish. They will need to create packages and launch some nodes and use RBase for debugging. So on this 3 hours class is just to explain to the students the basics of ROS and what they are going to use on the rest of the course, on the other classes that are to come. Okay, so on the first step, we teach this, and it's okay. Then on the second step, we have to create a list of the mobile robot concepts that we would like to teach. And that it depends on the teacher. There are some teachers that you prefer to teach. There is no unified curriculum about mobile robots, mobile autonomous robots. So it's not unified concept. So I'm going to show you the one that I am using, and I think that is quite complete without going into too much detail deep. And this is the list that I am using at present for teaching mobile robot navigation. The first one is basic wheel and steering control algorithms. Then we are working on using odometry-based navigation, especially dead reckoning algorithms. Then we go to move into sensors used for navigation. So that's very important to understand. Then we move into variation navigation, and I talk about extended Kalman filters. Then we move to the different steps for making a robot navigate. That's mapping, localization, path planning, and obstacle avoidance. And I explain in every one of them just a couple of algorithms. And that's all. Yes, I know that there is a lot more to show, to teach about autonomous robot navigation, but I consider that too much if you are doing these ROS-based practice classes. So remember that the students will have to practice a lot on that, so you don't have time to explain more things. I'm considering here a 1 semester course. It means 4 months. Okay, so that's the list of subjects that I propose you, but you can modify this based on your taste, on your experience, or on your, I don't know, maybe something in the board of the university that decides or something. You can modify. But the main idea from this slide that I would like you to get is that you don't have to go very, very deep in each one of those concepts, because otherwise you will have no time. And the main thing is that the students, they do program those algorithms by themselves, applying back to the robots. Okay, so that's the third step, is just to start teaching the first subject. Okay, so you have, remember, we have started by teaching ROS on the first class, then on the second class, then we start teaching just the subject. And how do we do this? So usually, the usual method is to start explaining about the subject. For example, if we take this list, let's take odometry-based navigation, for example. So imagine that I'm going to teach odometry-based navigation. Then I start to telling them, so the odometry is this, is that, and we have a frame. So the student is not going to understand that at the beginning, or I mean, they can understand, of course, but it's a lot more difficult. And it takes a lot of people to get out of the understanding area. So what I propose instead is that you make the students solve a problem with a simulated robot that requires this subject that you want to teach. Then, because they don't know about this subject, they don't know about the odometry on the first class, then they're going to realize that they don't know how to solve it. So if I want the robot to go to one place to another, they don't know how to solve it. Then is when you are going to introduce the concept, the theoretical concept that solves that problem, and you are going to make them implement in the simulated robot. And here I have the example of the odometry-based navigation. So when you make the robot go from one point to another, then the students, they need to understand that there is necessary to have a reference frame. And in this case, it's the odom frame. And then you can then introduce what are the frames, etc. But they will understand now what is a frame. I have explained many times what is a frame from the different points of view of the robot. And yeah, so I never get to make them understand until they need it. For example, the students, they don't need about the reference frame of the camera or the reference frame of the laser. They don't understand. So what do you mean? I mean, the robot is detecting with the laser the obstacle. So what is this laser frame for? And then is when you make them to put the laser, to put it, for example, in front of the robot or in the middle of the robot. No, better on the middle of the robot, at the center of the robot. And then you say to your students that they create a program that the robot stops, let's say 10 centimeters away from an object, from the obstacle, that it is up 10 centimeters, because the laser is in the center of the robot. If they try to do that without understanding the frames, they are going to make the robot crash against the wall, because the 10 centimeters must be added from the outside part of the robot, not from the frame of the laser. And that's when they understand, okay, so those 10 centimeters, so the laser measures are related to the frame of the robot, but not to the boundaries of the robot. Okay, so that's for the odom frame. And then they also need to compute the movement in that frame. By using this frame as a reference, they know how to make a reference of a movement, and then they can understand better the odometry equations that are used in order to compute the odometry. Okay, so let's imagine that we have explained this odometry-based navigation subject, and then we move to the next robotic subject, whatever it is. I don't know. It depends. So you continue explaining the next robotic subject in the same way. Let me go back to the third step to make you show is you make the students solve a problem with a simulated robot. They don't understand how to solve it. And then you introduce the theoretical concept that solves this necessity and then make them implement. So you continue with another subject. At some point in time, you keep on the list of the different robotic subjects, and then at some point in time, you are going to need some extra new ROS topic. Then, in that case, you can stop your theoretical teachings and dedicate another time. It doesn't have to be a session, it depends on the subject. And then you have to stop there and start teaching again about that specific ROS topic. For example, how to create their own messages. Or for example, as we talked before on the previous slide, is about the TF. So make the people understand the TF and the purpose of TF is difficult. But once they are inside the problems of robotics, once they have had some introduction into ROS and they have applied, make them understand what TF is, it's a lot simpler. So maybe now is the moment where you have to explain TF and dedicate the amount of time that you need. And once you have explained that subject of ROS, that topic of ROS that you need, then you move to the sixth step. That is continue with the next robotic subject and repeat this process until you end your course. It's going to the next robotic subject, you realize that you need to explain another ROS subject, then you stop teaching theory and explain about this ROS subject and continue for all the subjects that you want to teach in your class. Basically, that's it, the method. And the only thing that I will tell you is that you need to balance the theory and practice. And that's something that depends. I have found that it depends on the teacher. In my case, I do prefer a lot to do a lot of practice because I'm an engineer. I want results. I want to have the results of this. So I like a lot to have the more practice than theory, but it's just a matter of taste. Around 50-50 will be the ideal situation, but you can move around there. Okay, so let me give you 2 additional steps that I recommend you to implement for your students, for your classes. First one is to include a project with a real robot. Remember that we have been talking all the time about doing the experiments on simulations. Why simulations? Because then everybody can access the simulations in any place, and it's with different robots. So there is no problem on doing that. But if you are teaching about autonomous robots, you should make them taste how it looks, how it feels to do it with a real robot. And for that, you don't need to have a real robot for everyone, but maybe a couple of them, where the students have to create a project on that robot. And they will test it so they will create this project by using the different elements that we are going to talk now, and then test, at some point in time, test on the real robot. What I propose is to make small groups, like 2-3 people that they work together in order to solve this project. And how do I define the project? Well, first, I define the environment for the real test. So this project is going to be evaluated at the end of the semester, and this is going to be evaluated into certain conditions. That's the environment where this is going to be evaluated. For example, for those students that you can see here on the picture, they had to create a robot that serves coffees to the table in a coffee shop, and that's the actual coffee shop where they were going to be tested. So that's a real place. So you know what is the real place. Okay, then you have to create a simulation of that environment. Why? Because the students will need to practice to test their algorithms, and they don't have the chances to go to the real cafeteria all the time. So you provide this simulation of your environment, and then you have it ready for them to test and do all the tests that they require until they can put it back into test into the real robot. Then on the next step, you make sure that you have those robots available for the students for practicing, even if not at the cafeteria or your environment. They have to be at the robotics lab so that they can, at some point in time, transfer the controllers from the simulation system into the real robot and see what happens. If, for example, in this case, we are talking about navigation, so the robot has to create a map of the cafeteria. But you can test this also on the lab. So you can test if your algorithm is able to create the map in the lab. And then you can assume that if it is working on the lab, then it's going to work on the cafeteria afterwards. So you have to make sure that there is this time and this material ready for be tested even at the robotics lab. Then you have to indicate a deadline for evaluation. So it's going to be on that date that we are going to evaluate everyone's project. And then use your classes, some of the classes for practicing. In our case, we dedicate a certain amount of time of the classes for doing practice in the class itself. Why? Because it's a moment where they can interact with the teacher, they can interact with the other teams, and they can see in a group, they can see how it is the others are improving, what problems are the others having, etc. And then what I do recommend is that for the evaluation day, you create an event. So something that is kind of special is something that goes out more than just the exam going there and evaluating the project, but something more special, like bringing some friends, bringing some people taking pictures of the event, or even recording, etc., because that will make it more fun and also more closer to the real situations. When you are an engineer, you have to deploy your robot in a real environment, and it's a lot of fun, I can tell you, and they are going to love it afterwards, the students. So that's it. One additional step is to do this, and let me show you how we did it. For example, for the cafeteria. Here in this video, you can see the simulation of the cafeteria that was made by two students, and that I think that they went too far, okay, because they have created the whole simulation with many details of the cafeteria, with some of the posters, newspapers, even. So let me move it a little bit, and here you can see many details, even cups and the whole area. Okay, so we provide this simulation as an example for testing. I'm going to provide you with this simulation in a ROSject in a few minutes, so you will get this simulation also. Yeah, so that's a simulation, and then for testing, this is for testing purposes, so they can test here and see if it works and be more sure that the project will work afterwards at the real cafeteria. And if we go to the event, then we created this event for presenting the project related to this robot. So that's a robot that they have to use. Oops, sorry. So that's a robot, and the robot has to serve the coffees to the table. And these are some videos that we recorded at different moments, okay? Not only at the event. So in this moment, there was no event, not yet. Here we were making some presentations, some of the students, the robot, and then some friends that came to see the evaluation of the robot, and we did some tests, and that is actually fun. And also, why not to say, it puts a lot of a lot, no, but a little bit more of pressure to the students, and that's always very nice because they will learn more when there is pressure. Okay, so then related to the evaluation, I consider that the evaluation has to be continuous and not based on a final exam. And why this? Well, the reason is very simple, because the students, if you don't push them, they will not do it. They will leave everything until the end, and then at the end it's going to be a mess. So what I propose is that you do a set of exams. And in my case, I do 4 exams: the second, third, fourth, and fifth, and then the project evaluation. And then here there is another first exam that I'm going to talk to you about this one in a few minutes, in a minute, actually, about this. This is a special exam. So the exams related to the navigation, autonomous mobile robots are those 2. And then the project evaluation. So that's a continuing evaluation system, and then you can average at the way that you like the most. And okay, so maybe you are thinking, yeah, that's super cool, as what you are saying. So yes, I like it, the approach, but the problem is that this is a lot of work to be prepared and done. And that's first the problem. And then the second problem is, even if I prepare all this and the simulations and the code, and then afterwards it has to work in the students' computers. So that's also a festival of errors, because I don't know in your cases, I think that it's the same situation as for me, but the students that come to the university, they provide different types of computers: Windows, Linux, Mac, and each one with a different version, and it's terrible to make it work. So we have to prepare a lot of work, and it's difficult to make it work in the student's computer. So well, I'm proposing you a couple of solutions to those problems. First one is for teaching ROS. What I propose is that all the ROS materials, you can have all the ROS material already available at our Robot Ignite Academy. So we have created an online academy that is called Robot Ignite Academy. Let me click just very quickly here to the link, and let me log in. So theory, I should be logged in. Yeah. Okay. So and then here you can see that there are many different courses teaching ROS basics, either in Python or C++. It depends on what you want. And there are a lot of different subjects of teaching. So not only teaching ROS, but in case that you would like to teach about ROS navigation, so you have a course here, or perception and autonomous vehicles, many different subjects, even navigation in 3D maps, or understanding the TF for industrial robots. So you can use those courses here already made for you. So you don't have to create anything. It's starting here, the course, and you will see that you get the lessons here on the left-hand side. Here is the lessons. Let me check this chapter. For example, let's say ROS Topics 1. And then you can see these lessons that appear here, how to do the publisher, and the different types of code. And then here you have this, here on the right-hand side is going to appear here the simulation that is associated to that notebook. And here we have terminals for launching the commands, compiling, so you can get to the Catkin workspace, source, and get the packages that you have created here, for example. Those are some packages that have created at some point in time. And you have different terminals that you can use for launching, compiling, and creating your code. And here is the simulation that whatever you launch, it will affect this robot. So you have everything on the web, on a browser. So you can see that it's inside the browser. You don't need to have any special installation in your computer. So it works for Mac, Windows, and Linux, any version. And here we have the editor. So here you have an IDE, a complete IDE with autocomplete that allows you to create your code and your packages, etc. So you have the whole environment here for your students. You don't have to prepare anything. So let me continue here. So that's for the case of ROS and ROS-related subjects that you want to teach. And then also for these special classes where you have to teach about theory and combine this with ROS lessons, maybe and you would like to build your own lessons, simulations and code, then in that case, I would like you to consider to use the ROS Development Studio. That is something very similar to the Academy, but allows you to create your own lessons. It provides already off-the-shelf some simulations and code. So let me show you how it works. It's just a link here that you have for accessing the ROS.ds. And yeah, that's my development location. And let me see that I have here several ROSjects, what we call a ROSject. And a ROSject, it could be, for example, one lesson that it's explaining something about the subject of autonomous robots. For example, we have this one about Unit 5, about occupancy grid. So I'm going to open this ROSject. And this ROSject contains the lessons also that I have prepared myself. And you can use this environment to prepare your lessons yourself. So here you have the lesson in a Python notebook that you can, at any point in time, you can modify, edit, and change. So if I do a double click here, I can edit and modify, for example. And then what I do is to include here the lesson, the theoretical lessons that I want to teach to my students, with all the formulas and all these aspects. Remember that you can configure as you want. And then finally, I provide some code and some exercises that they have to do with this code by launching the simulations that are provided also. So in this case, they have to launch the Husky simulation here, and then the simulation is going to start. And we'll have here also apart from the lessons and the simulation that is going to appear here, we have other tools like the IDE for development. The same way, you can launch here RBase. You can create new packages in different workspaces, separated new simulations. So you have everything included here. And this tool allows you to create your own packages, your own lessons, including everything. So we package everything, we manage everything into what we call is a ROSject. And a ROSject is what I have shown you here. Is here. Yeah. So it's those lessons, those packages here that contain the lessons, the code, and the simulations. I'm going to share with you in a minute a series of lessons of ROSjects that contain lessons that I have already made for my students, so you can use them for your own courses. And what is interesting about the ROSject is that you can share those lessons with the students. So here in the list of ROSjects that I have here, I can press this button and then share with a simple link. This link with anybody, doesn't have to be your students, just with anybody. So anybody who clicks on that link will get a copy of my ROSject. And everybody will be able to execute in the same exact conditions as I prepared the ROSject. The lesson, the code, and the simulation. So if I paste, for example, here in a new lesson, in a new tab, this ROSject that I have copied there, then I will get a copy of so I have copied, so I have 2 copies, okay? So I have copied this Unit 5, so I have another one. So that's very interesting that you can share that easy with just a single link, because then you can share your lessons with your students. So you prepare your notebook, you prepare your simulations, and then you provide this link, and all the students will be able to practice as you have planned, independently of their computer. It doesn't matter. Then also you can, for example, if the students have a problem, you can make them send to you a link to their ROSject in order to, you can check their problem. So you don't have to have your environment prepare with the simulation that the student is doing, with the program that the student is doing. Just do a click on his link that the student has shared with you, and then you will have the exact situation that the student is facing and where he has some trouble. And also I use, for example, these ROSjects to send the exams to the students. So when we are in the class, and then I provide to them the exam just with a link. And then when they finish, they send me the link back, and I can correct in the proper environment the code, so I don't have to download their code, put it into my environment, and check if it's working, if it's not working, if it's a problem on my side, etc. And finally, that ROSject allows you to share with other teachers. So if you are creating a ROSject related to mapping, for example, or extended thermal filters, then if somebody has created this, it's very likely that you can access this and use it on your next class, so you don't have to build. Okay, so that's about ROSject, and I would like to tell you, we are about to finish, but I would like to tell you about a few extra problems that I have faced when I'm teaching robot navigation using this method that requires a lot of interaction from the people. And it's that, well, apart from learning about autonomous robots and ROS, it happens that the students that come to the class, they have those problems there. First, they don't know about Linux. They don't know about Python. That is the language that we are using for programming in ROS here. Or even they have problems in English, with the English. So what I do about that is to try to solve on the first class. So the first class, before starting teaching about ROS, on the first class, what I do is to provide a quick lesson based of Linux and Python. And I use those online courses that I have attached here, the link, you can get it and try by yourself. It's a basic course for Linux shell, the command line, and there is also a basic course for Python. And so the first class, we do all this about Linux and Python, and on the next class, they have an exam. Remember that I mentioned to you that I have here first exam. So that's the first exam. It's this exam that I mentioned. This exam is a simple exam about Linux and Python. Why? Because this is basics. I mean, this subject is very simple. Linux and Python is very simple. It's just that you put the effort. And in order to make the students to put the effort, you have to create an exam. So that's what I do. I use those courses for teaching them. Those are free courses that you can do online also. And I teach them Linux and Python, and then we do the exam. And about the problems of English, it's just a matter that I create everything in English. So they have to start learning about English, because I'm sorry, what is the language that is the common language for engineering, especially in robotics? Then they have to do it and to get used as soon as possible. So they have to do this effort for trying to learn everything in English. Please don't lower the level by changing your course in another language. That is not going to be good for the students. So that's the extra problems that I found. And then before we finish, I would like to share with you the following ROSject examples that you can use it. So I have created this list. I'm going to share those links on the chat. Okay, so on the first link, I have included a ROSject that teaches about autonomous robots, that it's low on theory and high on practice. So it teaches very little about the theory, but it makes the students to practice a lot. Then on the second ROSject, it's another ROSject that it contains a lot of theory and less practice. So by watching those, you can see how accommodate. So I have been doing a lot of experiments in this sense, and so those are two examples that I have used. Then I'm included here also a ROSject that contains the project. You know, the project that I mentioned about the autonomous robot that has to serve the coffee. So here you have the project that contains the simulation of the cafeteria. It contains the simulation in a reduced form because otherwise it's too big, the simulation, and then it goes very slow. So I have included here a reduced simulation, but it's good enough, so you can check. And also I have included here another ROSject that contains an exam. That is one of the exams that I did to my students a few weeks ago. So you can use it as an example also. And let me put those things into the chat. So you can click on them and then get the copy. Oh, wait, here. I need to get out of this and copy. So you are going to see the inner workings of this webinar, and that's very good. Let me copy everything so you can get here. Okay, and then, so that's it. So it's going to appear in a few seconds in the chat. So you can see here is the first one. So that's the ROSject for the autonomous robots lesson. And then I'm copying now the second one, that is the lesson high on theory and low on practice. That one is about this, what was about, oh, grid mapping, for example, is this one. Then on the third one, it's about the project that describes how to do the project. And then the final one is about the exam. So if you want to use those, then just go to the links, you click on the link, and then you will be directly redirected to your ROS-DS account, and a copy will be created. If you don't have any ROS-DS account, then don't worry, this link will also work. You can press on the link, and then it will redirect it to a place where to create your free account. It's a free account. You can create free accounts for this, and then once you have created, the project will be copied to your zone of ROSjects. And basically, that's it from my side. So I hope that there's some questions here, and I'll be happy to answer you. In the meantime, so here in the screen, you can see some of the ROSjects about domain randomization that we are about to release in a few days. So let me see here in the chat if there are some questions. For example, it says real GSK say, are you suggesting that an instructor can use some of the course material prepared by the Robotic Night Academy for his courses? And then I'm suggesting that, so actually a lot of teachers, they are getting Robotic Night Academy for teaching to their students. So what they have, we have a license system for academies, for educational institutions, for educational institutions. So then the students are practicing inside the Robotic Night Academy at the same time that the teacher is teaching using the material that is in the Robotic Night Academy. So that is the permission for using it, of course. Then Real GSK also says, also to the best of my knowledge, the Robotic Night Academy courses are not free. Am I right? Yes, that is right. It's not. They are not for free. It's the way that we have for so to finance our company. So that is why. Gotham says this webinar is the introduction of the Robotic Night Academy. No, it's not. No, it's, I have provided a lot of material that doesn't have to be any related to Robotic Night Academy. I'm suggesting just that because I think it's very, very cool in order to teach ROS, and it's the easiest way to teach ROS to your students. and many universities are using it around the world. So that's why only. But you don't have to take this. So you can take, for example, the ROSject that have provided. These are for free. You can do whatever you want with the code that is inside and the notebooks. It's okay. So, and if you don't like the Robotic Night Academy, then you don't have to take it. That's okay. So Kashif says, what about implementing on real robot? Like if we implement navigation algorithms in simulation, it's easy, but doing the same on robots is tough, as we need to ROSify the robot. Yes, that is right. That is not a simple subject, and ROSifying a robot. So what I would suggest you, let me suggest you two things, okay, Kashif? First one is that first you should use a robot that is already ROSified. For example, a Turtlebot robot. So you can provide to your students something that is related to, it's a robot that already runs, because otherwise it's too much things. They have to learn ROS, they have to learn autonomous mobile robots navigation, they have to ROSify also the robot. I think that is too much for one semester. So what I suggest first is that you provide a robot that is already it's already ROSified, like a Turtlebot, or there are many, the Summit XL from Robotics, Tiago from Power Robotics, Fetch, that one that you can see now on the screen, for example. Then second thing is that you can use, if you want to teach them about how to ROSify the robot, you can do it at the beginning of on a previous semester, I would say. And for that, let me tell you that we have here at the Robotic Night Academy, we have, for example, a course that teaches about that. It's this new course that we have released a couple of weeks ago. It's building and ROSifying a robot from scratch. And if you can see, is that here, let me show you here the summary. So it teaches even how to create the physical robot. We provide even the parts where you can buy with direct links to buy the components, how to create the simulation of that robot also, and how to connect to the physical robot, the motor drivers, and we show autonomous navigation in two senses. One is line following using the camera, always is using the camera in this case. And this one is using the Orbis lamp, also using the camera, not laser. In this case, it's not for laser. And finally, it's some class about applying this for deep learning on your robot. So that's the second suggestion that I would say. And yes, so next question, let's go to the next question is, Kashif still says, like we need to interface with motor drivers, write code for odometry as in simulation, gazebo, conditions odometry. Yes, that is right. So that's what I mentioned that the the course covers. Then Nancy Ripplinger asks, what robot do you suggest? Turtlebot? Yes, Turtlebot is a good choice. It's the easiest one. There is now a new version. If you like to have smaller robots than Turtlebot, then you can use the Turtlebot 3, for example. I also recommend robots from ROS Components store. So there is a store that is called ROScomponents.com. Let me put it here on the chat. And you can use that store for buying all the types of robots. So that's the store where we buy the robots that we need. And it's very cool. The people of that store, we have no relation with them, just friends, and I like their job a lot. That's why I buy there, and I recommend you there. And there are, so for example, there is also another one that is very interesting that is called the ROSbot by the company Usarion. Also, that one is also very cool, and it's small. It's in the type of size, let's see, more or less like a Turtlebot. I would recommend that one. Then, can you use melodic instead of kinetic? Yeah, I mean, where? For example, in the ROS Development Studio, yes, you can use it. In this case, you can see that as the screen is indicating ROS kinetic, but you can create projects with ROS melodic. Then, can you use Ubuntu 18 instead of Ubuntu 16? Yes, with ROS Melodic, and we have Ubuntu 18. Have a look there. When you create a new ROSject in the ROS Development Studio, you can select for which type of Ubuntu and ROS version you want to use. Then Gloria, I see that Gloria is there, but has deleted the message. Hello, Gloria. Then we have Gokham that says AMCL algorithm use that reckoning. No, AMCL algorithm is using odometry, but it's also using the laser to in order to update the localization of every one of the particles. So it's not dead reckoning at all. It's a SLAM technique. Actually, it's a particle filter. Then Nancy says again, have you used Baxter and do you use Python? Yes, we use Baxter. And Baxter, we have some ROSjects already there using this with Moveit, for example. And you can check if you, let me see, it's called the Moveit tutorial. We have all the videos teaching about that. Moveit Basecamp, something like that. And there we use well, we don't use Baxter on that one, we use the Sawyer, but it's the same. And there we teach about this, how to use Moveit for this robot. And it's some videos on YouTube. You can see, you can watch them and also even get the code, and it's ready there. Check for that. Then send a list of ROSified robots support Chase. Okay, yes. So and on ROS components, you can find that list. For example, all the robots that are sold there, they are ready for with ROS. Then Kashif says, can we implement ROSLAM using monocular cameras as mentioned in your course? Yes, of course. Just have a look at the course and you will see how to do it. Then Gloria says, agree, Robot Ignite is the best tool. Thank you, Gloria, for the teaching ROS. I have tried teaching using the tutorials of ROS4, and that's another option. That is right also. This is a really good system. There is no quicker methodology. I thank you, Gloria, for your comment, but also I do agree. I mean, just give it a try and you will see that it's just right. Then Arturo says, in your experience with ROS, what are the best practices to test the behavior of robots under different parameters? Using different config files called by a launch file, several simulation instances. So test behavior of robots under different parameters. Okay. So yeah, so the best thing is to have, in my opinion, is to have different config files. And then you can, for example, you can create different config files, each one for one of the configurations that you want. And then you have a single launch file that accepts a parameter. This launch file, when there is a parameter where you indicate which kind of the configuration you would like to load. Then you say, oh, so ROS launch, my package, my launch.launch, and then your option is configuration 2 dots equals 1. Then inside this launch file, you have to have the logic created for capturing this parameter, and then based on that, load one of the configurations or another. So I will do it in this way. Then Kashif says, can you share any link to write ROS code for publishing odometry data from wheel encoders of a differential wheel robot? ROS code for publishing odometry data from wheel encoders. Okay, so nothing comes to my mind right now, but I think that in Robotnik pages, they have these, for the dynamic cells, I would say that there is a package, if I remember well, it's ROS dynamic cell, something like that. You look for that in Robotics. Robotics is the company that creates the dynamic cell and has created some packages for that. So I think that if you look there, you can find what you are looking for, because you will see the examples of how the dynamic cells are publishing the odometry data from the wheels, from the dynamic cell itself. Liubomir says, what controllers do you use for the robot with mechanical wheels? Okay, I don't know. What do you mean? What controller? What do you mean? You mean is a position controller, an effort controller? Well, that depends on the motors that you have. So mechanical wheels, it depends on the motor and also on the control board that you have that controls the motor more than the wheel, the mechanical wheel. Then Liubomir says, is there any course for combining a robotic platform and robotic hand in one project? Yes, I think that yes, that if I understand properly, okay. So there is a course here that it's ROS manipulation in 5 days. Let me go here to the courses. And here there is a course that is called ROS manipulation in 5 days. And here you have, as you can see, there is a robot. The robot that is used here, 3 robots are used. One is a universal robot, that would be the robotic platform. And then at the end, there is a gripper. It's not a hand, but it's a gripper. Maybe that it's good enough for you. So I hope that this is useful for you. Here it teaches how to do everything and how to add perception and how to do the grasping with those robots. Maybe those one, also we use the fetch and the RB1 robot, and they do also have some grippers and arms. Maybe that's what you are looking for, is ROS manipulation in 5 days. Okay, so then more question says, Goham says, automatically not using AMCL, am I right? No, sorry, no. No. So AMCL, it uses a particle filter, and that's the typical SLAM solution. And in a SLAM solution, typically you need the laser for doing the sensor update of the prior, and then you also need the odometry in order to do the position update of the position of the robot. Every time that your robot moves, then you detect how much it has moved based on the odometry. But this odometry, it has some errors, and then at the end you compute how much the robot has moved based on the odometry, and then you use the laser for correcting this position that the odometry is saying and that is not right. And you use for that, then you can use, for example, a Kalman filter or a particle filter to do this. But you use both the laser and the odometry in AMCL. Then Ahmed says, I never used ROSject before, but I'm wondering if I can work with libraries like OpenCV or any other Python libraries outside of ROS. Yes, of course, we have some OpenCV libraries there installed and many others for TensorFlow, for scikit-learn, for many others that you may need. And if in case that you don't have one and you require, just send us an email. There is a forum there, link, and then, sorry, a forum feedback question link, and then you can just send it, hey, please, I need this library. And we usually, if it is not super complex to install, then we do it very, very quickly. So you can get the library installed, and then all the people that is using ROSject will have also access to that library from that point on. Then Joe says, how would the licensing work for students? I could see this replacing textbook cost. Your suggestions appear need 4 months of Robot Ignite Academy. How much do you require for the construct? Okay, the construct, there is a free tier. And so the construct, you mean the ROS Development Studio, okay? The construct is the name of our company. And then we have two products. It's the ROS Development Studio, and that one has a free tier. What you can see now on the screen is the ROS Development Studio. And that's a free tier for a certain amount of hours per month, more than enough in most of the cases. Only if you need more extra hours, and also especially you need GPUs or more CPU power for special things, then is when you have to pay. But otherwise, it's free for you. And for the Robotic Night Academy that contains the lessons done for teaching specific subjects, then you have to pay some amount. And we have for individuals that they have to pay a monthly license, but for educational entities, we have a special pack for amount of users that is a lot cheaper. It's a lot cheaper. So you just pay for a license for 10 students or for 20 in a pack like this, and then all of them, they will have access. You as a teacher can control what they are doing. You can control the access and remove the access to from one person to another, etc. So let me put it here, the web page where you can see all the details about this, about teaching ROS. Let me just, so you can see here, where all the details about how to do it, how it works, the academy. So let me see more questions in the meantime. So let me see that I don't miss. Liubomir says, what is the best way to combine simulator and a real robot in one project? Okay, so the best way is to have the simulation of your robot that you want to use as a real robot. So you have to have the same simulation, and your simulation has to be as close as the real environment where you are going to use this robot. And then that's it. So you just create the packages with ROS. With ROS, it's quite simple, because whatever you use in ROS in the simulation, you just copy the packages from the computer of the simulation to the computer of the robot, and that is all. From the ROS Development Studio, you can do it directly by establishing a VPN from the ROS Development Studio to your robot network, and then you can launch it. Then what else? So then here, let me see. Jeff is asking, I will teach a class of 30 students from January 10 through May 15. What would be the cost to me, professor, and to the students? Okay, so that's a very good question. And then, Jeff, how it works is that for 30 students, we have different packages here. Let me show you. Yes, let me show you. It's very, very simple. So here is, okay, I don't have here the link. Okay, let me come here. Wait. What happened here? Don't touch. Wait, we are having problems, and I need to. Okay, so now I cannot go because it has started the timer that is blocking my YouTube. Wait just a second. Let me see here and here. Okay, no, it's not that one. It's this one. Okay, online ROS courses for universities, and here we have the prices for 30 students. So that is the total amount per one semester. So it's the total amount that it will be to be paid. So usually the students doesn't pay anything because it's the school that pays this amount, and then your 30 licenses plus the teacher, that is complementary for the teacher, then they can access to the platform for that amount of time. So basically that's how it works, the pricing. Then what else? So let's see if there is another question. Is Joseph saying, is there a plugin for Mecanum robots in Gazebo, like a steel driver controller plugin? Yeah. I'm sorry, Joseph, I don't know about this. I don't know. really, I think that you are moving into a direction that I don't know too much. And Jeff says that, okay, so there are some problems. Will you provide a manual book on exploring ROS with robot via email? I can find it in ROS Development Studio. Yes, so we are going, yes, to send it by email. Yes, so we are going to send you to all the ones that you registered to this webinar. So you are going to receive this now, this afternoon. So let me see. But this Limbo Mir says, but the sensors will publish the same data, I mean, from simulation and real robot. Yes, okay, so that's the purpose of the simulation, that is publishing this, the same information in the simulation as in the real thing. Okay, so the simulations are never exact to the reality, but are more than close than enough for most of the things that you will do with your students at the university. So you don't have to care about that problem or not be too real. And okay, thank you, JR. Thank you. So I think that we are finished today here. We have reached the final question. Denisa is saying also thank you, welcome. So Gotham, he says that if we got an AMCL lesson, yes, on the Robotic Night Academy, there is a lesson that is called this ROS navigation in 5 days. And there is where we teach how to make use of AMCL for navigating with ROS. Okay, and thank you very much, everyone. So we are going to finish here. Thank you, Gloria, for your super nice comment. Thank you, Jeff, for your questions. Andrea, thank you for being there. Soren, thank you very much for being there. Kashif and Goham, also thank you very much. So it's been my pleasure, and I hope that this is useful for you. If you have any questions, just put the questions beneath the video, and I will answer them very, very fast. So I will take first priority for your questions here. And in case that you would like to learn more about ROS, let me tell you that we are doing a live class on ROS every Tuesday at 6 CET, 6 on the afternoon, CET, Central European Time, every Tuesday. And it's live, it's open, it's on YouTube on our channel. Maybe it's interesting for you or for any of your students. You are welcome. And the manual, Gianfranco, yes, we are going to send it right now through email, don't worry. So you got the ROSject now, and the manual is going to be sent in just a few minutes. Thank you very much, and remember to keep pushing your ROS learning.